Hello, my name is Kevin, and I'm a rising senior based in independent Silicon Valley. And my project is the robotic hand. So my motivation for doing this is because my parents have pushed me to do computer science a lot. And after taking physics during sophomore year, I was actually inspired to do something more mechanical based. And I want to step out of my comfort zone. So I picked this project because, well, it's a lot of hardware. As you see, I have to work with 3D printed parts, servos, fishing lines, all of that stuff. And the fact that there's two over there shows you that's just, cool, it's out of hand. So the way that this works is that there's two main components. I have the glove and the hand. So when I put the glove on, it will mimic the motions that I make with the hand. So the way that this works is that there's two main parts, the glove and the hand. So on each of the fingers of the glove, you have these flex sensors, and these flex sensors are connected to an Arduino Uno. This is a microcontroller, which means that I can read the inputs from the flex sensors and detect how much each one bends. These then cause the servos to bend. So these servos, as mentioned earlier, are connected by fishing line through the fingers. These fishing lines act as tendons on an actual hand. So these servos can only pull these fishing lines. So sort of like how a tendon within your finger can pull a finger to either curl it or extend it, the fishing lines act in the same way. So in terms of the major challenges that I faced, you have already heard before about working with the fishing lines, working with the power source. So I'm going to talk about something that many of the other people who built hands actually breeze through, which is working with the glove. So for me, the glove was actually really challenging, even though this shouldn't really have been. This actually took me more than a week. And to be honest, I'm not really sure why I thought this would be so easy. When I went to this project, I thought the easiest part would be working with the most difficult part would be working with the electronics and writing the code. But that was actually the easiest part for me. What was actually the most difficult was working with all the hardware. And the glove is a prime example. So this is a printed circuit board, or PCB. And I have all these flex sensors and resistors and these analog inputs, or these yellow wires, which are soldered onto it. And I actually had a lot of difficulties sewing these flex sensors on, and for this PCB, I actually messed up and I had to resolder all the components. In the final stage, when I was attaching this PCB onto the glove itself, I actually messed up. One of the wires came loose. I tried desoldering it, and that failed, and I had to throw out like 2 days worth of work. So this was one of the most challenging things for me. Overall, in these 6 weeks, what I learned is that, Ben sort of touched on this in the intro, engineering is nothing like what you learn in the classroom. So in my physics class, in my math class, in my computer science class, you have one answer to one problem. These are really, really simple. But in mechanical engineering, there are so many things that can go wrong. And all I can say is I learned how to troubleshoot, how to get around these problems, and thank you, BlueStamp, and thank you for listening. With that, are there any questions?
Just wondering about for all the hand project, why are you guys using this line instead of other type of string?
Okay, so the reason why we're using fishing line is because of two primary reasons. First of all, this fishing line is very strong. As you know, fish are pretty strong things. And if you want to reel one out, you're going to need something that has a very high tension tolerance. So this fishing line is rated to carry more than 50 pounds, which the servos are not able to deliver 50 pounds of force, but they are very strong. Secondly, they can become very tense. So in order for these to really pull the finger all the way down, you're going to need a lot of tension to do that. And that's what these fishing lines can deliver.
Which one?
Chaitanya.
So, how are you powering the entire thing?
So I have two sources of power. I have this 7.2 volt battery, which, as Annabelle touched on, has been the root of a lot of problems dealing with this battery. So this is what powers the servos. I have this external battery. normally, before today, I powered this with the laptop, but this provides the voltage into the Arduino board.
Yeah, I have a follow-up question before Ben asks his. Did you use something to go around the problems?
Which problems?
The
There's
one
any
with
of them.
the 7.2 volt battery.
Okay, so I actually tried 3 things. First of all, I tried using a linear regulator to curb my problems. And what a linear regulator is it's basically like a buck converter. So you're able to lower the voltage going into the servos because the servos are rated to function between 5 and 7.2 volts. But the battery actually delivers around 8 volts when it's fully charged. That was my first solution. It didn't work because I just couldn't get my circuit to run. The second thing I tried was using prefabricated buck converters. So I used 2 of them, the XL4015 and the LM. So the XL that I mentioned earlier, it didn't work out. The LM worked a lot better, and that's what I'm currently using.
It looks like you're really cramped inside the wrist forearm area with so many servos. How were you able to fit all those in there?
Okay, so they're actually meant to fit really snugly, but one thing that I found out was that the servo horns were way too long. So if you don't know, the servo horns are these things that are attached to servos that can turn. So I actually had to work with a Dremel to solve the last 2 holes on those.
So like on my project, 2 of my fingers moved with 1 servo. So did you do the same thing? And which 2
Yeah, I
fingers?
did the same thing, but what I found out was that actually, so I'm able to make these turn all the way, but what I found out that servo is actually not able to deliver enough power to do that. So that's why when I did it, they can only turn about like this much. So they still have this knuckle joint that's not able to turn. All right, thank you.